Okay. Close this. All right. I hope you can hear me. Good. Okay, good. Thanks for your response. All right, and it's good to see that we have quite a number of people here this afternoon. Okay, so I'll proceed to discuss a little bit further on your assignment. And before I start on that, this week is also consultation week. All right, so I'll be seeing each and every one of you further this week to look at your assignment in more detail. Yeah. So now this week I want to discuss. Last week I discussed with you 4 and 6. Sorry, 4A and 6A. Okay, so this week we'll be on the same task 4, but we are looking at roundabout. So last week we looked at channelization, and this week we'll look at roundabout. Okay. Now this week's lecture will also be on roundabout. So I will jump a little bit into lecture because I know you have not learned that part yet, and I'm briefing you a little bit advanced for your assignment, and then we'll move into lecture on Thursday. So at this session, in this session, I will also jump a little bit into lecture just to give you a preview of what is coming up in the lecture and how is that tied to your assignment. All right. So task number 4, propose and design intersection treatments for the intersection of the access road with Kuching Samaran Expressway using the following options. So we are looking at B today, roundabout only. Right. So why I put an only? You don't combine that with signals. You don't combine that with other forms of treatment. Yeah? So the treatment is just purely a roundabout treatment. Okay. To provide entry and exit point, and the treatment must allow movement from all directions. Draw your proposed treatment, draw your roundabout to scale in AutoCAD, complete with control devices such as signs and line markings. Please refer to appropriate standards and guidelines. For the drawing, your proposal must take into consideration the availability of space and land and safety of your users. Be clear with the objective of your geometric design of these intersections. For example, whether you are designing it for safety, by lowering the speed limit, or designing it for, okay, this one is for unsignalized. All right. So if we look at the layout, if we look at the layout of the road, this is basically a T intersection. And last week we said that we are to treat this intersection with unsignalized channelization only, unsignalized intersection. All right. So this week, instead of treating it with channelization only or unsignalized intersection only, how about we try putting a roundabout in and see how we can manage the flow around here. All right. And for that, your drawing will have to be to scale in AutoCAD or equivalent platform. You can use AutoCAD or other software that you are familiar. If you are familiar with Civil 3D, go ahead, use it. I'm fine with it. Okay. It's the outcome that I'm looking at, not the software that you are using. All right. Okay, now I just jump into this week 4 lecture for a bit. And if we are to look this one I've already presented and discussed this with you previously. And if we are to look into this, you see this is a T junction. And this is a very simple basic T junction because this is a two-lane two-way, two-lane two-way from this side. And then you have another two-lane two-way here. Okay, this is signalized. Sorry, not channelization. This is signalized, right? But the idea is that if we convert it into a roundabout, you see that the roads are not exactly straight. With a roundabout, it tries to slow you down through the geometry, through how the roundabout is shaped, how the roundabout, the layout of the roundabout will help to slow down the vehicles. So if we look at this, this by the way is American. FHWA, this is America. So if we look at this, they are driving on this side of the road. Okay, so the roundabout goes like that. Ours in Malaysia, in Australia, we enter into the roundabout this side, yeah, because we are driving on the left side of the road. So you enter the roundabout this side. So for this drawing, for this figure, we'll have to look at it this way. As you are driving on the right side of the road. Okay, so you enter into this, you see that there's quite a curve here. That is basically to slow down the vehicle, and then they curve. And if you want to exit here, you go there. If not, you make a turn and then exit on this side. Okay, so if you look at this, the exit is pretty straight. That means when you exit the roundabout, it's tangential to the roundabout. This is a tangent to the roundabout. Okay, so my point is that you don't just smack a roundabout here and then expect the road to be still straight. Okay, so you can curve the road a bit. You see how the alignment has been slightly modified so that the road is slightly curved toward this side, rather than for this signalized, it is straight. All right. Now I jump into lecture 6 a little bit. Okay. All right, in lecture 6 for this coming Thursday, there will be 2 parts to this. First part is to look into the design and geometry of the roundabout. The second part is the analysis. Yeah. So task 4 is on the design and the geometry of the roundabout, the design layout of the roundabout. Task 6 of your assignment is on the analysis of the intersection, both unsignalized and roundabout. Okay, so if we look at the lecture for this week, you have 2 parts. The first one is on the geometry. Okay. All right. So if you look at the geometry, ours is this one, left side driving. Okay. So we enter into the circulating lane, and you have different exit direction, and you exit here. So if you look at the exit, it's quite straight up, quite tangential to the circulating lane, right? Okay, I'll go through this with you a bit later. Yep. So then what you need to know a little bit for today is at least this. You have the central island. This is the central island, and the inscribed diameter is here. Okay, and from here until here, this is the inscribed diameter. So usually when we decide how big the roundabout should be, we are talking about the inscribed diameter. Okay, so the size of the roundabout is with reference to the inscribed diameter. This is a single lane, by the way. This is a single lane roundabout. Yeah. Okay, so there are various ways of how we can design a roundabout. Now, with a roundabout, usually we want to deflect the vehicle path so that the vehicle slows down, and then it becomes safer. But at the same time, we also want to use roundabout to cater for the traffic flow. So that means you design for capacity. So capacity usually it's governed by the size, the inscribed diameter size of the roundabout, as well as how many lanes going into the roundabout. But when you want to design for safety by slowing down the vehicles, then we are looking at deflection path. So how we deflect the vehicle path is through the island, the angle going into the roundabout. So you can do it this way with a bit of blister here, so that your driver is kind of forced here, and they will have to enter into the roundabout like that. Okay, so there are many ways we can have offset. You see that this is slightly not quite aligned with this. Yeah. Okay. So this is deflection path again. This is for 2-lane. This was single lane. Okay. And then turning template. Okay. Now turning template is meant especially when you have very small roundabout. You see this radius is 15 meter, so that means your diameter is about 30 meter. Very small roundabout. If you have been to campus, or if not, you can also Google the map. You will see that the roundabout outside of campus, diameter-wise, is really big. We are talking about hundreds of meter. The one that you have for your site, the one that I gave you, this one, this roundabout, if you look at this, if you go and measure the size, that's roughly about 200 meter. Okay, so if you are talking about very, very small roundabout, this is 15 meter. So then you have to use turning template. Okay, but I think this will not be the case for your assignment. I don't think it will be that small, but we'll see how. Okay. Excuse me. All right. Okay, I will skip through this first. All right, so I've put in some guidelines here to help, but otherwise you have to go and search for roundabout design from Osroads. Okay, so if we look at in particular, just the splitter, the approach and the exit, we are talking about this. So if you look at the number of lane, as you approach the intersection, as you approach the roundabout, this is your Kuching Samarahan Expressway. Okay, so you have two sites, Kuching Samarahan Expressway. This is a 4-lane 2-way. Okay, and it's dual carriageway. So if dual carriageway, then we are looking at, this is the splitter island. Okay, so for this splitter island, you see that it ends here because after that, the road is a single carriageway. So that means it doesn't have a median. But in your case, this is a 2-lane 2-way with a median. Okay, so that means you are looking to continue this here. So it doesn't stop. You continue this splitter island into the median. All right, then your road will have a median. Okay. Yeah, and if you look at this, this is 4 meter. This is also about 4 meter per lane. Okay. When we approach towards the roundabout, usually the lane width will also increase in size a little bit. Yeah? So if you have a normal 4-lane 2-way, if I go back to this, if a normal lane here, if I just cut a cross section, I would get 3.5 meter, most likely 3.5, and 3.5 on this side as well. All right, so which means you get a normal lane width. But if you put a roundabout here, as you approach towards the roundabout, the diameter size, the lane width will also increase slightly. So at this average width is about 4 meter. Average because you start from 3.5, you move into this. This part could be 4. Here it could be 4.1 meter. So it's on average, we are looking at about 4 meter here. All right. This is because your vehicles are on a curve. And when your vehicles are on a curve, we have to widen it a little bit to allow for that curve part. Okay. Yeah. So this one is for rural roundabout, very long splitter island. Not so much your case. Very long so that it actually gives warning so that your vehicle, when they come and approach from here, when they see this, it's a sign to tell them that something is different in front. Yeah. Okay, so your case I think would be this, but continue on with the median. Okay, and then of course pavement marking and signage. All right. Yeah, so something like this. Okay, so at the end of the day, after you've completed task 4, at the end of the day, this is something that we will see the outcome. Just a drawing for task 4. For task 4, it's basically a drawing complete with line marking and signs. All right. So what we see, what is the outcome that we get is something like this. All right. So you have, so you see this one is a splitter island that continues with median. This is what you have for this part. Yeah. So as you approach this, there is a median here. If you want, you can widen the median a bit, that's fine. And then your roundabout is here. And then you have the splitter island and then goes back to a 4-lane two-way with a median. Okay, so if you look at this drawing, yeah, so this case, you have a splitter island here and then it goes back to a median. So at this point onwards, it is a 4-lane two-way, a normal 4-lane two-way, which is somewhere here. All right. Okay, then complete it with all the different signage, line marking, arrow marking, and so on. Okay, there's a question here. So we need to do exactly like what is in the slide for signs. Okay, if you look at these signs, it is telling you the directions. Yes, you will need to have this sign similar to this. Because the name of the locations here are all different. Okay. Any other question on this? Okay. Got it. Good. Right. Okay, then pavement marking. Okay, pavement marking. You will see two different types of marking here. We are using concentric marking, whereby in the circulating lane, you see that this dashed line, this is continuous. For Alberta marking, the dashed line is like this, and then it goes into the exit lane. Okay, ours would be using a concentric type. All right, how the different line marking. So you can see further on that. This one is a single lane. We don't consider other users. You don't have cyclists, bus, or pedestrians at your roundabout. So I think you don't need to consider those. Okay. Okay. Street lights, I think not necessary to be incorporated into your drawing. All right. If it is sufficient to have something like this. Okay, but of course with dimensions. Yeah. There's a question, I think. Okay, also no need to consider heavy vehicles. Good question. Do you need to consider heavy vehicle? Yes, you need to, because the road, let me see. Okay, if you look at your existing traffic survey from task 3, the vehicles plying this road, you would have heavy vehicles. Okay, but having said that, do you need to specifically consider heavy vehicles or not when you put in your roundabout here? This is a 4-lane two-way. So when you have a 4-lane two-way, when you put a roundabout here, it will not be too small where your heavy vehicle cannot negotiate around it. Okay, let me just scroll to that. Yeah, usually when we need to consider heavy vehicles is when you have a single lane roundabout, because when you have single lane roundabout, usually the inscribed central island as well as the inscribed diameter is quite small, and for that matter, for a left turn, probably not too big of an issue, or that might be an issue. Through movement, I think not too big of an issue, but when you have to turn, this is what happened. Okay, so when you have small roundabouts like this, then yes, we need to really think about heavy vehicles. But when you have a 4-lane two-way such as this, even if you put a very minimal diameter size, I think the heavy vehicle will still be able to traverse along or around your roundabout. Okay, so I think that would be catered for due to the nature of this road environment. Yep. All right, then you may ask me, the next question would be, how big is your roundabout? How big should your roundabout be? Let me scroll to that. Okay, that would be the analysis part. Okay, determine the number of entry lane and circulating lane. Yeah, so you can determine it based on this. How many entry lane should you have, particularly for this site, this approach? Okay, you have 2-lane, 4-lane two-way, so that means 2 entry lane. But how about this leg? Do you provide 2 entry lane or do you provide single entry lane? So you can make use of this graph to determine whether you need 1 lane or 2 lane or 3 lane roundabout. Okay. And then inscribed diameter. Inscribed diameter, you can assume a value for your inscribed diameter, and from the value that you assume, your analysis would show whether it is sufficient or not. Okay. So okay, just no need consider for pedestrians and cyclists. Yep, you don't need to consider for pedestrians and cyclists. Okay, let's just assume that there will be very minimal pedestrians, minimal to none pedestrians and cyclists. All right. Okay. Are we okay so far? Any other questions? Okay, I see some thumbs up for now. All right. So yeah, so make use of this graph, and then if you have now, if you know, let me just go back to this for a bit. Okay, if you know the width of your existing road, then you might want to look at your inscribed diameter to be slightly bigger than your current existing width. Okay, so then you work backwards. Let's say you know this is 7 meter plus 7 meter on 2 sides, so that'll be 14 meter, and plus the plus the median width. So let's say median width, give it 5 meter. I don't know what's the width here, but let's say you just give it 5 meter, or you can measure it. Yeah, you can measure it if you want to, and so that would total up to 14 plus 5, about 19, 20 meter. So then if you're looking at 8 meter. All right, so if you know that this is about 8 meter, about 19 meter, then you know that this is about 8 meter. So this is 8 meter, this is 8 meter, 4 meter here, 4 meter. So we use the same value. So that's about 8 meter here, 8 meter here. So that would be 16 meter. Okay, so if you are looking at bigger inscribed diameter, it definitely has to be bigger than this 19 meter just now. All right, so that's how you can give it an estimation or assume an inscribed diameter for this. Okay. Okay, I have a question here. Do we need to consider the speed of the vehicles when designing the roundabout? Yes, a good question. Do you need to consider the speed? Definitely. Okay, the speed is considered here. All right, using this formula, I think you are familiar with this formula from your road engineering. Now, what this means is that, okay, if you know the speed, or if you set the negotiation speed, V is the negotiation speed. That means how fast you travel within the roundabout, how fast the speed inside here. Typically, the roundabout speed, we are looking at about 30 to 40 kilometer per hour, about that speed. Smaller roundabouts could go lower, perhaps 20 kilometer per hour, but with a larger one, we could go about 30 to 40. All right. And if, let's say, you fix it at 30 kilometer per hour, so that's your negotiation speed around the roundabout, 30 kilometer per hour. You can work out the E and F. Then you can calculate the R, which is this R. Okay, the negotiation path, right, or the deflection path through the roundabout. Okay, so yep, the speed is fixed, or fix it, and then you can calculate the R. What is the R here? So that you get a deflection path like this. I hope that makes a little bit of sense. I know that it may not make a full sense at this point,
Dr. Elizabeth,
simply because you have not. Yeah. Yes, go ahead.
the speed is approach speed into the roundabout, is it?
You are referring to
The
this?
formula, yeah.
No, this one is inside. You're already inside.
Oh, inside.
The
Okay.
approach speed is here. This is approaching speed. So if, let's say, your road speed limit is, for this road, if let's say the speed limit is 70, 80 at that area, yeah, so as you are approaching, the speed will definitely slow down. Sorry, the speed will definitely slow down. It could slow down as much to, if let's say you don't stop here, you can move on because no vehicles here. Then you are looking at slowing from 80 to, say, about 40 here. So when you enter into the roundabout, if you put this as 40, then you are looking at 80 slowing down to 40, and then 40 maintain within the circulating lane, and then you exit at about 40, and then the speed will start to pick up again.
Okay, okay, I see.
All right, good. Okay. Are we okay? Are we good on this? I don't see any question at the moment. Okay, so I think I'll move on to the analysis for a bit. All right. If you still do have questions on this, yep, please drop it in or just switch on your mic. Okay, then I move on to task 6, which is the analysis. But for this analysis, not on this intersection, not on the roundabout that you design. Okay, analyze the performance again in terms of all these different measurement. Okay, performance measurement, capacity, average delay, queue length, and number of lane. So what you have learned from unsignalized intersection last week, as well as this week's tutorial, for roundabout analysis, it's built up from unsignalized. Okay, so then analyze the performance, which are all these parameters, all right, of the Stutong roundabout for existing condition and Stutong roundabout for future condition with the additional traffic volume generated from the new development. Okay, so what it means is that you are not analyzing here, but you're analyzing this one. Okay, so you know the volume from task 3, from the traffic count, you know the volume, the turning movement volume. So you have to analyze this based on the layout of this intersection. Okay, so you have to analyze this you have to analyze this roundabout based on this based on the layout here. All right, I believe some of the lanes are specific left turn lanes, so that may not need to be analyzed for the roundabout. Okay, some are 3 lanes. I believe this one is a 3-lane roundabout. Some are 2-lane. All right, so when we analyze roundabout, if it is a single lane, it's easy. Let's not talk about single lane here. Okay, we'll do that in tutorial. But when you have 2-lane roundabout, one of it will be dominant lane, one of it will be a subdominant lane. Okay, dominant simply means the lane that has higher traffic volume. Yeah. You know that when you approach the roundabout, you can choose drive on the left, to drive on the left, or to drive on the right lane. If you have 2 lanes, and if you have 3, you can choose either one. Now, for 3-lane roundabout, you will have 1 dominant lane and 2 subdominant lanes. Okay, so the analysis is really based on the layout that you have here and the volumes from your existing traffic survey count. Okay, so that is for B. All right. How we do the analysis, I think you will learn that in your lecture and tutorial within these 2 weeks. So Stutong roundabout for the existing condition. Okay, so this is simply from step 3. Traffic data from step 3. Then you have Stutong roundabout for future condition with additional traffic volume generated from the new development. Now, you will not use the entire traffic volume that are generated from the new development. Okay, only the traffic volumes that are okay. Only the traffic volume that will be coming into this leg as well as exiting this leg. Okay, because those are all right. Okay, your development is here. All right, so in order, if let's say from your trip generation, you have the number of volumes, which is then analyzed in part A. Okay, so part A, you already have your channelization treatment for future condition. So which means you would know the volume here at this intersection. Okay, the unsignalized intersection. So then from that one, you would know how many would be traveling to this direction and how many would be traveling here so that it can turn in back into this. All right. Those volumes that are turning towards this direction, as well as coming from this direction into the development, we don't need to consider those because it will not have an impact onto this roundabout. All right. So the future condition for this intersection will only be traffic volume that are coming out into this roundabout, as well as coming from this roundabout into the new development. Okay. Yeah. So then, okay, then the traffic volume that comes to this roundabout, then you have to remember under task 5B, you have the trip distribution. Where would the possible trip ends? In this task, you are to make your judgment. Where would they go to? If the trips are going through this roundabout into various destinations, then you may make use of those information, and your new development, you already have that. So you already have this part. Okay, so make use of the information from here and add it to your existing traffic volume to analyze for this roundabout. Okay, so your task 3, which is your existing traffic volume, you already have the turning movement count. Okay, and from task 5, you have the trip generation, trip distribution, and to analyze your Stutong roundabout for future development, you only consider trips that are generated from the new development that are coming in this direction and is distributed to various legs, because you need the turning movement data, or rather you need the turning movement so that you know where they are turning to. Otherwise, if let's say you have 200 vehicles from the site coming to this direction, then 200, where do they go to? Okay, so you need to know where they would turn to. Yeah. Then if let's say out of the 250 goes here, 100 goes here, another 50 turns here, then you add on to the existing traffic movement, yeah, from step 3. Okay, I hope that is clear. Yeah, the traffic movement are obtained from step 5, while the existing traffic condition are from step 3. Okay, so then you analyze it according to the layout of this roundabout. Okay. So the analysis, I think, should be quite similar to what you will be learning in your lecture this week and tutorial next week. Yeah, I think particularly in tutorial, because tutorial you'll deal with 2-lane roundabout. Okay, so if 3-lane, nothing, this one is a 3-lane. What's that? For 3-lane roundabout, it's just an additional step, which is you will have 2 subdominant lanes. Okay, maybe at this point when I say dominant and subdominant, it doesn't make quite much sense to you. But I think with the tutorial next week. Wait, when is the tutorial again? This week is week 6. Next week is tuition week. So in 2 weeks' time. Yeah. Then you should be able to see how we analyze that. Yeah, how to know dominant and subdominant lane. Okay, maybe I just brief you through that a little bit. Let me see if I have that here. Oh, my example is single lane. Okay. Never mind. Let me just try that. Okay. Now, if you look at this, okay, for a single lane. Now, for a single lane is quite easy, because for a single lane, the different movements, if you If you look at this, this is a conversion. For roundabout, you definitely need to convert. This is turning movement. Okay, this is what you do in your task tree, turning movement count. You need to convert that into a circulating flow diagram. Okay, a flow diagram. All right. Now, for this diagram, we will have 3 items. The red color one, these are entry volume or entry flow. The green ones, these are all exit flows. Okay. And the purple ones, these are circulating flows. All right. Now, for a single lane roundabout, the entry flow is quite straightforward. You just add everything up from here, 116, 133, 53, and you get the total entering into the roundabout. All right. But for a 2-lane roundabout, you will have 2 lane here. Okay, so 1 lane and another lane. Now, when you have another lane, let me try and draw this. I think that will be easier to understand. Just give me a second here. Okay, let me unshare this and I'll share the drawing. Okay. All right, so what you have is that when you have 2 lane, and this is your U line, and this is the splitter island. Okay, so you have the circulating lane here, and this is the central island. All right, so when you have 2 lane, where's my mouse? Okay, usually what happens is that, at least for Malaysia, the arrow is like this. Okay, so when you have 3 volumes, true, right turn, and a left turn volume. Let's say this volume is, let's give some numbers so that it's easier to understand. This one is 300. True movement is 300. Okay, and then this one we have 50. And this one is, say, 100. All right. 100. Okay, so now if you have this volume, if this is a single lane, the entry flow would be 450. Just add everything up. But if you have a 2-lane roundabout, if you're driving in Malaysia, in Kuching in particular, you may either drive, if you want to make a left turn, you either drive on this lane, or you could drive on this lane if you like. Okay, and if you want to make a through movement, you can also drive on either one of these lanes. Same goes for right turn. Now, for analysis sake, we would then consider, if you want to make a left turn, okay, if you want to make a left turn, you would drive on this lane, left turn. And if you want to go through, you can also drive on this lane. Okay, and you can also drive on this lane, And if you want to make a right turn, you drive on this lane. All right. And this is how driving in Australia is according to this kind of movement. All right. So that would mean for this entry flow, for the outer lane, the entry flow is 100 plus, we give it as 300 divided by 2 for simplicity's sake. Okay. All right. So which is then equal to 150 plus 100. So this is 250. And for this side, this is 300 divided by 2 for the true movement, and then plus 50. So this is 200 vehicle per hour. Okay, so then the higher volume, which is this volume, the higher volume, this becomes dominant lane, and this one, the lower volume, this becomes subdominant lane. So this is dominant lane, and this is the subdominant lane. All right. So if you have 3 lanes, same thing. You just have to make assumption where the movement for that particular lane. If you have 3 lanes, okay, then you have to make assumption. Maybe this lane is only for right turn or for left turn. This lane is for true movement, as well as right turn. Sorry, left turn, and this lane is for true movement and right turn. So if that is the case, the combination would be different. Then your total volume would be different. Okay. Now, why I use half here? Why I just divide by half? This is for simplicity's sake. If you want to put percentage to it, it's also fine. Yeah. Sometimes we observe that drivers, it may not be, those going through may not go half-half. They may go about 60% on this lane, 40% on this lane. So if you want to do that, that's fine as well. Not an issue. Just that for tutorial later, you will see that I use, or rather Miss Bong will use half, just for simplicity. Okay, so this is how we determine the dominant and subdominant lane. Yeah, I hope that explains to you. Any other question? I don't see any questions on for now. Okay, so for the greater vehicle per hour one is considered dominant lane. Yes, exactly. That's correct. All right, so if you have 3 lanes, I think one of the leg you have 3 lanes, then you will have 1 dominant, 2 subdominant lanes. Okay, got it. Okay, good. Any other questions? Okay, I don't see any question for now, so I assume that at this point you get something out of this session, I hope. Okay, so I think that's about it for this week's briefing. Okay, so I'll be seeing you guys for consultation in your respective groups. Now, please get ready everything when you meet me. Next week will be tuition week, so we will not have any session next week. Okay, we'll be back again in week 7. All right, so take care until I meet you in your groups then. All right, bye.